Вроде идет.
Да, даже меня показывает.
Все отлично. Сейчас тогда в 10 ровно включу запись. Если что, другая запись, она до сих пор конвертируется у меня. Как
М,
до конца будет конвертироваться, я потом вам скину в личку в "Телеграме", думаю.
мгм.
Еще вчера обсуждал я есть такой товарищ Рустам Жалилов, он спортивный директор «Сокола» и, собственно, один из главных апологетов сим-рейсинга в Казахстане. Это гонки на компьютерах. Вот, новое такое движение прикольное. Ну,
Мгм.
вот, и тоже задает вопросы, может провести между школами какой-нибудь чемпионат Формулы-1, где они команды свои выставят.
М.
Вот, так что тоже обсудим.
Ага, так, мы в прямом эфире,
Да, я поэтому и
учитывайте
говорю,
это.
я его рекламирую. Ходите в Race
Мгм,
Place.
мгм. Вот
Если бы вы
смотрите, у
могли.
нас участница, я так понимаю, Аружан Турсунбекова, она не член нашей команды.
Такая, если мы в эфире, то уже что скрывать.
Ну да, ну,
Ой, ладно, извините.
так.
Я её удалил.
Ну, мы ее обратно пригласим.
Хорошо. Насчет еще раз приветственной речи хотел спросить. Мне просто рассказать
Мгм.
о правилах, какой будет потом второй этап, когда он будет, и все. И еще раз просто представить судей, кто они,
Да,
чтобы
да.
все,
И слов никому давать не надо.
все без проблем.
Ага. Потому
Если
что
опять
у нас команды сразу с 10.
Все, понял вас. Так и
Мгм.
сделаем.
Мгм.
Главное не
Щас.
забыть начать запись. Introduction session. Окей, тогда я потихоньку буду уже принимать участников.
Мгм.
Ну, вчера все, конечно, очень классно прошло.
Не,
Я прям, я прям в шоке в легком нахожусь. Ну, то есть, понятно, что уровень видели разный, но некоторые участники прям реально меня в хорошем смысле слова шокировали. Вот ждем, когда все эти зумеры поколения альфа придут, так сказать, в автоспортивный бизнес, и в Центральной Азии будет очень серьезный всплеск вообще автоспорта. Вот. Надеюсь, у инженерных судей такое же впечатление.
Коллеги, доброе утро.
Доброе утро.
Доброе утро.
Доброе утро.
Здравствуйте.
Хотел спросить, а участники знают, что им нужно прийти в 9:55, потому что сейчас я вижу очень мало участников.
Видимо, будут в 10. Давайте в 10 начнем. Ну, получится, все сдвинется на 5 минут.
Все без проблем.
Мгм.
Доброе утро, меня слышно?
Да.
Отлично.
So I think we can start because I see that the first team is here. So again, I would like to introduce the judges, but I would like to introduce myself first. I am your moderator, Amin Imamberdiyev, and your judges will be Kimhanbek Sultan, Ibrahim Alibek, Rustem Yermekov, I'm sorry, Max Krada, and Aruzhan. I would like to say about the rules and 4 minutes to answer questions from the judges. So the first team is, and about the results will be announced on the 5th May, and about 2 weeks you will have your super final competition. If you have any question, please ask in Telegram or you can ask in chat here. Okay, so we're gonna start with the first team. Please, the representative of the D-Moon team, could you state who is your representative? And I should give the access to share their screen for the presentation. D-Moon team.
Sanjar.
It's who?
Sanjar.
Okay, Sanjar. Okay, I'm giving access. Can you share your screen?
Yes.
Okay, great. Okay, I'm starting counting. Are you ready?
Yeah.
Okay, I'm starting counting your time now. Good luck.
Good morning, respected judges. Today we are going to present our project from the moon. Next. We are the moon, a team of 4 students from NIS Almaty Medeu, united by ambition and drive to compete at the highest level at STEM racing. Our name reflects our mindset, aiming high, pushing limits, and turning challenges into results. Each of us plays a key role from design and promotion to research, marketing, and engineering leadership. Together, we combine creativity, precision, and strategy to become not just a team, but a strong and competitive force.
Our design process started with creating several 3D concepts, as you see on the screen. And we have 5 main goals: high speed, low drag, balanced weight distribution, and rear wheel support. We analyzed the YouTube videos and other guides from other websites, and we created our 3D model in the Fusion 360. During development, we modified the shape to reduce air resistance. Next, we used CFD analysis to test airflow and identify turbulent areas. Based on the results, we adjusted body shape and reduced unnecessary drag. So next.
So if we say about our research, we research using a CAD and CFD analysis, and we researched other groups projects, and we developed our 3D model by checking on these projects and Bernoulli principle.
So Jandos.
Marketing 6 slides is marketing strategies and materials. This slide presents our strong brand identity and marketing approach. We developed consistent visual style across all materials, including team apparel and promotional sets. To ensure professional and recognition, our strategy positioned the team as a high-performance engineering startup, helping us stand out and communicate value clearly to both audience and potential partners. Next slide. Seventh slide is sponsorship and ROI. This slide outlines our structured sponsorship system and the values we offer to partners. We create tiered sponsorship packages with clear benefits, such as branding opportunities and media exposure. We also demonstrate measurable ROI through audience reach, digital content, and engagement, ensuring the sponsors gain real visibility and impact from support our project.
Valdolet.
Our journey began in 2025 with our first experience at the Startup ID Fest. Soon after, we expanded our ambitions by creating a new rocket science team, the Platinum. In 2026, we achieved third place at NSS SCA and earned an invitation to the ISDC in the USA. Additionally, two of our members reached the finals of the Aero competition in Astana. At the same time, we are building our social media presence to present our team professionally and grow our impact. All this experience prove our adaptability, fast learning, and the ability to perform under pressure. Key strengths that drive us forward in STEM racing.
Next, this is a bibliographic which we use. We use platforms like SimScale and Autodesk Fusion Shot 360. And yes, we did use AI, but we used only, but we all, but we checked some sites for productivity of our project.
Thank you for your attention. We're ready for your questions.
Okay, great. So now you're having 4 minutes for your Q&A. The time goes now.
Hello. Do you have 3D model? Can you show it?
Yes. Let me open the Fusion
Okay.
360.
How much iteration you make of your 3D model?
We created two models of our car and of our car design and checked it in the sim scale.
In which program you use for simulation, aerodynamics?
Sim scale, as we said.
Okay.
And what is the result of your aerodynamics analysis?
Ahmed.
Ahmed, you here? Maybe another questions from market side? when we waiting 3D model?
Question. When you were modeling, did you think about how the car would be actually manufactured?
Yes, we thought about it. We thought we can like print it on the 3D printer or use the materials that our school can provide. So we also thought about it.
Mhm.
From the marketing side, do you have a structured plan of your marketing campaign?
Yes, we do have.
Unless
Because, we created our sponsorship on different layers, so different companies, small or big, can buy our subscription, and it also helps them to see
Do you have a
our.
do you have a target on international companies or local offices, there or local offices, or to the national companies?
I think we do have on international companies because we plan to, if we pass this stage, we're going to start our site that will provide also information about our sponsorship and how much it will be cost. So I would think it will be on different languages to attract sponsorship from different countries or international.
Sorry, your time is
Okay.
up for the Q&A session. Thank you so much.
Okay.
Okay, great. So now I would like to invite another team, OGME, who is the representative. I should give you access for the sharing your screen. Okay.
Они, кажется, тебе писали, Аружан. Ты микрофон включи сперва, Аружан.
Hello,
Hello.
I'm an OGMA team representative. I want to say, yeah, I want to say you we have a force majeure. Our captain has an asthma
You're
attack. Yeah, so
okay, I see. Okay. So we got you.
can we rearrange the meeting for our team, please?
It depends on judges.
Oh, sorry. What's the name of your team?
OGMA, OGMA.
So I think you wrote me that one of your teammate is fell asleep, right?
Like the second one is in America right now. You know that the worlds of FTCs like right now, so that's why one of our teammates is also in America and she's not answering the messages.
But other members are here.
Like 3 of us.
Can you do it by yourselves without one of the members?
I can ask them. Yeah, probably if it's okay for judges.
But it should be a little bit faster as we have other teams to come. So you should decide it like maybe in a minute or in 2 minutes.
I mean, we cannot change the time of our presentation, right?
It depends on fully on judges.
So yeah, our team is asking to change time for like maybe hour or 30 minutes if it's possible, please.
Okay, the next team, Quran
You're
92. Are you ready? If we will,
Hi.
okay.
Yeah, we are.
can you
Thank
You
you
are
very
ready?
much.
Okay. What's
Thank you.
so I should give access to Aslan, right?
Yes, please.
Okay. Great. So can you share your screen? Just confirm it.
Okay, I want to share it right now. Так. Can you see my screen?
Yes, we can.
Nice.
Okay. Now I'm giving you 6 minutes to present. Your time goes now. Good luck.
Okay, Murtaz, you can begin.
Hi, Orion Racing is a STEM racing team from the team number 92 built a strong foundation of robotic experience. Our team combines engineering, design, business to create a competitive and impactful project. Uh, our project is based on the idea that technology drives progress. We focus on developing engineering solutions that combine performance, efficiency, and innovation while representing Kazakhstan in STEM.
So, Amara, as you can see, there are 5 members in our team, and also there are 3 mentors. 2 of them came to us from the KBTU Engineering. They are currently students at KBTU University, and also one is he's currently employed as a designer for the USTEM Foundation. I just need to add that. Thus, please continue.
Team identity. We developed 2 logo variations to represent different aspects of our team. The first one, the dynamic version, reflects speed, energy, and our connection to the team number 92, making it ideal for racing, visuals, and social media. The official represents professionalism, engineering, and international ambitions, and it used to for presentations, sponsorship, and formal communications. So next, Aslan.
So here's branding. I mean, our branding is consistent across all materials. It includes the teamwear, documents, and even the digital content that help us maintain a strong and recognizable identity. So the project initiation, I need to highlight that we had only 1 week to prepare. That's why the timeline execution is very short.
Engineering process. Our engineering process is based on iterations and the preparation. We started with a basic concept and improve it step by step using analysis and using.
Okay, so we also need to highlight the control and monitoring. So to keep the project under control, we used task management and responsibility allocation. So we tracked it daily, so that you can see we tracked in 3 colors, so that everything will be done in time. The marketing strategy. Yeah, Ayşenur, please continue.
Yes. Hello. Marketing strategy. Strategy. Our marketing strategy focuses on showing the engineering progress, not just the final result. We use social media to document development, share technical insight, and build a connection with the STEAM community. Our goal is not just reach, but meaningful engagement with people interested in engineering and innovation.
We successfully built a competitive car using limited resources by focusing on effective and smart design and marketing. Every part of the projects, from engineering to marketing, was supported without increased spending. However, our next step is expand our sponsorship network, improve finance tracking, and invest more in testing and development.
So what do we offer for our sponsors? Is of course we provide value for each partner. We also provide place for their logo on our car, and we can also share with some digital courses online. And if we go to the engineering and CAD part, I mean the core design principles was drag reduction, weight optimization, and flow management. As the main philosophy was around that we don't need that much of downforce, but we need to reduce drag. That's why we chose the biomimicry inspiration. So you can see we were inspired by the kingfisher bird. So you can see its body is very smooth. That's why we chose it as the main shape for our car main body. Also, the front plate of our front wing is also inspired by the spinal part of the fish, as you can see here. And also, we used a parametric design in Fusion so that we could change some parameters of the model by just adjusting the number. As you can see, we flowed this by this chart. So actually, all support structures are made so that the drag is minimized. To get that, we chose an NACA 008 airfoil. As you can see, its drag is very low. That's why we chose it.
Your time is
And
up. That's it. From now, you're having 4 minutes to answer Q&A. So your time goes now.
Regarding marketing, I heard enough, so I think my colleagues from technical side will ask more questions.
Yes, please. There is a lot of that we can discuss on the technical part, as you can see.
Do you have only final version of your car on 3D modeling?
Excuse me?
Do you have only a final version of your car?
Yes, we do have the final version of our car. It's presented right here.
No, I mean, do you have only final version, right? Do you have like first version of your car and like it's developing?
Actually, we had it's the second version of the car. First one was a bit boxy, and we chose to get rid of it and start again. That's how we got this second design.
Can you show us how your 3D model was changed, like between first version and final
at first, at first I tried to simplify it as much as I can. So the first car had only one wing at the front wing, but now it's segmented, as you can see, so that the airflow will gradually increase its angle of attack by 4 degrees. That it was made that because we need to, as you can see in this chart, so the negative 4 degrees is almost creates as much as drag as 0 degrees, so that we get our downforce, but the drag isn't increasing. That's the first thing. The second thing, the main body of our car. On the first, I tried it to make with the loft, with the loft tool in Fusion 360. However, it created a lot of sharp edges, and that's why then I made it just by the intersection of the sketches I made, and then piloted it a lot. Also, we added this drag reducing shapes on the backs of the back of the wings, because the first version of the car it had low pressure zones on the back of their wheels. That's why.
What is your final drag coefficient of your car?
Honestly, we finished this cut pretty recently. That's why we haven't still done the CFD analysis. However, I mean, we tried making it like flowing with the data from the airfoils so that everything will be nice. I hope we'll do that pretty
One
soon.
more question, first question. Do you know how you will make your car? Do you have a plan of making it?
Yeah, of course. So the main body will be manufactured from the CNC machine, from the block the STEM Racing provides us. And other things, as you can see, it's the front wing, the back wing, also the wheels. They would be manufactured, they would be, I mean, 3D printed so that their shape will be very precise and efficient. As you can see, we can even change them. We made that so that we could get a pit stop award. I mean, the nuts are located on the sides so that you can change the wheels or other parts pretty convincingly.
Good. Here IV carbon. You use
Sorry.
produce carbon. Okay.
So that's it for the time. Sorry for interrupting. Thank you for the team. So now I am
Thanks for the attention.
inviting.
Thank you.
Thank you. I'm inviting the Meridian team. Who is the representative that I could give access to? Meridian. Okay, I see that here is the Meridian's team. Meridian's team, could you answer? Meridian?
Yes. We are
Okay,
here.
so I'm giving access to you. Just confirm that you can share your screen. Okay. So your presentation time goes now. Good luck.
We are Team Meridians and we are racing the future, and now we will talk about our team. So let's introduce us, and the role of our team is.
Hello, my name is Inju. I'm as time leaders of Meridian. I was responsible for managing the teams, coordinating everyone's task, as well as contributing to the car designs. In our concepts, I responsible the starting points, the origin from which every line begins.
Hello, my name is Shania. I'm the one who did the logotypes, and I'm in the charge for social media accounts, and I'm the one who did the color grading for teams and machine.
I'm Janelle. I'm marketing manager, and I manage our team's branding, social media, and communication strategy. And I also build our team's public image.
Hello, I'm Russell, the engineer for Team Meridians. I developed our 3D model and optimized aerodynamics, and with one goal in mind, velocity. Simply, but I'm the line of the team that answers for the speed of our car.
Cheers. Yes. Russell. Okay, good. And why we deserve to win? Because we Our key engineering focus in aerodynamics, weightful distribution, structured efficiently, and performance optimization. Our car is a result of real engineering and designing based on physics, not just in design. Every element from the diamonds of airplane was optimized for the performance efficiently and stably. We combined analysis, testing, and teamwork to create a car built for the competitive success.
Our logo is designed to reflect speed, direction, and the innovation. The central element is styled the alpha M shape to resemble a laking track, symbolization, movement, and performance. The arrow elements represent the forward rotation and ambition and continuous degrees.
Engineering, aerodynamic body design, optimized while geometry, lightweight internal structure, balanced mass distribution, car dimensions, length 195 millimeters, width 61 millimeters, height 43 millimeters, improved stability, reduced drag, structure, hexagonal Latin design, lightweight construction, high structural strength, wheel design, larger rear wheels, stability, smaller front wheels, less resistance, optimized contact with aerodynamics, rounded body shape, no sharp edges, optimized airflow, reduced turbulence, increased speed, mass distribution, low center of gravity, rear pieces balance, improved stability, better traction, solo-2 system, rear placement, direct thrust alignment, efficient energy transfer, reduced energy loss, pilot hollow, pilot under hollow, adjustable balance, lightweight hollow design, improved airflow, reduced weight, engineer constellation, reduced drag, optimized weight, high stability.
Okay. And now I want to talk about our marketing strategy. We choose Instagram as a platform of marketing because by Instagram we can build a strong and recognizable same brand. So how we will work? Our content plan is engineering process behind the scenes, team introduction, car development, final result. We will post it into content types as the posts, short videos, and stories. And maybe you think that by just posting video we cannot make marketing to our car, but I don't think like that because we will post video that will be driven by purpose, and our purpose is the content goals, educate, inspire, and engage. So by posting video, we will inspire young people to become interested in engineering too. And thank you for your time, and that's all.
Yes, your time is basically also up. So you have now 4 minutes for your Q&A. Your time goes now.
How much iteration
Please,
you
can
make
you
in
show
your
your
3D
3D
model?
model?
What? Show 3D model.
Alibek, you say.
3D model.
Can you repeat the question? I didn't hear.
Can you show us 3D model of your car, please? Like, which software did you use for making this model?
To make this model, we used Blender mostly.
Do you make some kind of analysis to it?
Analysis of what?
Aerodynamics.
Yes.
Can you show it?
Wait for the engineer.
This car design is based on three main principles: aerodynamics, stability, and weight optimization. First, overall dimension. The car's length 195 millimeters with 68, 70 millimeters and height.
No. We ask about aerodynamics testing. You use maybe soft simulation, another program to test or simulate aerodynamics of your bolide.
Yes, we need a drag analysis, maybe analysis of the wing, or maybe just weight analysis, structure analysis, dynamic analysis.
We don't do simulation, but we analyze it.
Okay.
Okay, regarding your... Okay.
Do you think about how you produce this bullet? Which material you use? How you produce it?
Yes, about manufacturing, please.
So basically, mostly we used plastic as our team leader decided to, and so mostly it's plastic, I can say.
Okay. 3D printing technology, yes?
Yeah, of course.
Okay. Maybe another question I don't have.
Okay, regarding your sponsorship strategy, do you have only a marketing plan for social media, or you have some ideas how to work with potential sponsors?
I think now we plan only by social medias because nowadays is the most popular platform to communicate with people.
But what about communication with potential sponsors? How do you like to reach them, and what can you offer to them?
So sorry to interrupt, but the time for this team is up. Thank you so much. And now I am inviting the Skyrest team. Skyrest team, are you here? Please say me your username.
Hello, yeah, we are here. We are ready to present our slides.
Okay, I'm giving you a permission. Just confirm if it works, and you can share your screen.
Okay, just a second.
Okay, good.
Кто у нас есть?
Okay, we see your screen.
Okay, can you see us? Yeah.
Yeah, we can see you. I can also spotlight you. Okay, great. Everyone sees you. Your presentation time goes now. Good luck.
Yeah. So, hello everyone. We are Team Skyrest, and now we are going to present our team slides. Let's move on to our team. Yeah. So, our team consists of 6 persons: captain, head of enterprise, digital, 2 engineers, and manufacturing. The first 3 are responsible for advertisements, and the next 3 persons are responsible for our Balit 3D.
And let's move on our team identity. And for our team identity, where our team identity is not just a visual, it is a system that defines our
how we design, how we perform, and how our system is working. The first of all, our logotype. Before we are creating this logo, we are very thinking how we can create a logo, the type of logo that contains the energy, the motion, the aerodynamics, and the speeds in one element. And the final result is our logo that you see in the screen. It contains in the center element, we have a centralized element that represents our speed and the motion, our energy, and the wings near are represented the aerodynamics and the speed. And for promoting our team outside the race, we're creating our merchandise and etc.
And here is our design process. This slide shows our full design evolution process. We didn't just create a final model, we went through multiple iterations. Each one improves the aerodynamic performance of the car. Starting from the version A, our focus was mainly on basic structure and the rule compliance. At this stage, the geometry was simple but not optimized for airflow. And in version B, we began refining the shape. We introduced smoother transitions and improved the body curvature and reduced the flow separation and stabilized the airflow. And finally, the version C, we achieved our optimized design. Here the surfaces are fully refined, the airflow is smoother, and the overall drag is significantly reduced. And this process reflects our engineering approach, analyze, iterate, and optimization. And in the next is, instead of questioning how it works, we let us physics speak. In version A, the airflow is chaotic, as you can see. And this means energy is being lost and the car is not efficient. So we didn't redesign randomly, we redesigned with purpose. And in version B, we started controlling the flow, we smoothed the surfaces and reduced sudden geometry changes. The airflow improved, but it still wasn't optimal. And then we pushed further. In version C, where airflow becomes clean, attached, and consistent. The airflow follows the body instead of breaking away. And this is where performance comes from.
And next, we'll talk about marketing and marketing strategy. So we didn't just build a 3D CAD, we built a business where we detail it meticulously, find out everything, and our target audience was student, general public, and F1 STEM competitors, which and people in this age often interested in this type of competition. So, and this is our budget. So you can see how we spend our money to trade ads, inspire of new gen and social media. And in the next slide, you can see our activities such as TV promotion, cinema advertisement, 22-meter billboard, and student presentation, STEM competitions, and support our local business. So this type of actions are developed to our led to us to improve our marketing and marketing strategy and to build our brand Skyrace identity. So let's move on to our digital media. As you can see, we have a YouTube channel in which we proceeded the SAT lessons, 3D lessons. In the Instagram, you can see our page, well designed with a lot of connections. And in this TikTok page, you can also see our connections and other stuff. So I want you to mention videos in these pages. And additionally, we have our sponsors, which we find now they are just helping with the stuff like learning, hosting events. But in the future, we plan to make our connections more deeper. Let's move on to our site.
Okay, for promoting our team identity, we're creating our site. Yeah, here. And in this site, you can see our team, how team members, and the main features in this site that we have is the simulations, and for helping other teams to testing their ballots, we're creating our simulations that calculated the aerodynamics of every type of ballot and calculated the approximate time how the ballots will perform in the race.
Yeah, so to conclude, we didn't just proceeded the ballot, we didn't just made the car, we just built a system in which everything is taken into consideration. Thank you for your attention.
Okay, great. So now you're having 4 minutes for your Q&A. Good luck with that.
One short question from marketing. Why you want to use outdoor advertising of your project with billboard?
Yeah, so actually, now in our Schengen, we just noticed that these kind of advertisements are very, well popularized. So we just, select the street in which a lot of cars are in traffic, and that's why a lot of, a lot of guys from the another schools might know about us more because of this big advertisement in which, which is seen by everyone in the street. Actually, that's why we just select this kind of advertisements
to engage sponsors, partners, and competitors to this type of combinations. We decided to make a billboard which actively engaged local people to this
Thank
type
you.
of.
Got it.
Technical question. What material will you use to produce your car, and do you know how you will produce it?
Can you please repeat the question? I think the internet is breaking up a little bit.
How you will produce your car, and what is about manufacturing?
Manufacturing.
We did our design from 3D printer, which available in our school, so you can see it in our portfolio. So we didn't consist this type of manufacturing in our presentation because it is consisting already in our portfolio.
What kind of materials do you use? What kind of plastic, metal? I don't know. Do you know what the material main part is will be?
For 3D printing, we will use PLA filaments, and but for real competition, we should use the balsa wood, and it's often used in body of the car.
Why balsa wood?
Because it's very light, and it's easy to design it, like shape these curvatures.
Do you have the experience to using CNC milling machine before?
Yes, actually we have, because in our school there is a small version of CNC stomach. CNC stomach.
What about aerodynamics? What kind of software do you use?
We used ANSYS and the sim scale.
So you can see, we'll show our checkings.
Short question, how much iteration you make of your 3D model?
I think we made 3 iterations.
We did 3 iterations. So the first was the main body of our car, and the next stage was
rear wing. Yes, rear
building wheels, and this final stage was building
Not
other
stage. Not stage.
and
About iteration, you make first model, it's not good, something, and you make another. How much iteration you make?
And can you see it? Here is our yes. Here's our first version of our car.
Sorry to interrupt, but your time for Q&A is also up. Thank you for the Skyres team for that presentation. And now I am inviting Orkan RT.
Thank
Who is
you.
the representative of the team? Orkan RT.
Hello, it is our determine.
Determine? Okay, I'm giving you access now. Can you share your screen?
Wait a minute. Run. So do you see me?
We see. Okay, now we are seeing your screen. We see your screen.
Выбери вот это, нажми на вот
Okay,
это.
so I'm giving you 6 minutes to present. Your time goes now. Good luck.
Okay. So, hello everyone. I am team principal of our Racing team. Today we will go through our job done briefly. So, including extracts from our portfolios, we'll go with. Our verbal presentation is adapted to ICL strategy in comparison to other team, which is innovation, collaboration, and learning. So, since this verbal presentation is not the final one, dear judges, not all of our aces will be played, and you can see them in one of our portfolios. Our innovation process is defined by structured data-driven interaction within strict competition regulations. We developed 5 different car generations, each representing an alternative design concept rather than a direct improvement over the previous one. This approach allowed us to explore multiple aerodynamic solutions, in parallel testing variations in geometry, proportions, and the surface transitions. Using ANSYS simulations, each concept was evaluated based on airflow behavior, pressure disruption, and the resulting forces, enabling us to compare their performance objectively while ensuring full compliance with the regulations. As an example of our research and the development approach, we conducted detailed wheel optimization using PEA in Autodesk Fusion. For example, 2 concepts of wheel. First is a 4-hole design, and the second is a 4-spoke design, where analyzed terms of moment of inertia, peak stress, and also minimum safety factor. This allowed us to understand the trade-off between weight reduction and structural integrity. By relying on simulation data rather than assumptions, we ensured that our design decisions were both justified and aligned with performance requirements while maintaining compliance with the competition constraints.
At this point, we will come to the collaboration. At present, our main sponsor is Pole Position, the most popular Formula 1 merchandise distributor in Kazakhstan. Unlike many other teams, they have made a direct financial contribution by fully covering the cost of our team uniforms, demonstrating real investment into our project. In addition, we have reached a verbal agreement with Qazaqstan regarding the manufacturing stage. However, the deal has not yet been finalized due to the May holiday period. Another key sport is F1 Kazakhstan, the largest Formula 1 community in the country. They actively promote our goals through Instagram and Telegram and feature our logo during the race event broadcasts. Alongside them, we have our brand new partner, Ecomiken. They support our sustainability in direction that help us to maintain ecological sustainability.
And you know what? We actually keep talking about how we impacted STEM racing, but let's answer the question how STEM racing impacted us. In project management, we developed a deeper understanding of both securing outcomes and adapting to unexpected disruptions. One of the key lessons was the importance of effectively closing sponsor deals, meaning the transition from the initial contact and interest to a confirmed and formalized partnership. Through this process, we learn how to maintain communication, present clear value, and follow up consistently. I have already reached a verbal agreement with potential sponsors, which have already been mentioned, and plan to demonstrate this learning by successfully closing the deal before the upcoming super final in 2 weeks. Another critical lesson was managing uncontrollable risk within the team. When our head of enterprise, Tomorza, was hospitalized with a concussion, it created a sudden gap in our workflow. However, our digital lead, Sharafat, was able to step in and temporarily take over these responsibilities. This experience highlighted the importance of flexibility, cross-functional awareness, and having a team structure that can adapt quickly to unforeseen challenges without disrupting overall progress.
So through our enterprise journey, we gained so much valuable insights to build effective and sustainable marketing strategy. And one of our key achievements was growing our audience over 700 subscribers, which was not the result of mass outreach, but targeted and structured approach. We learned that engaging youth audience requires using communication styles which are relevant to them, such as social medias, interactive content, and peer-driven promotion. So another important lesson was balancing fan-based engagement and sponsor value. While building an audience is essential, it must also translate into clear visibility and return on investment for sponsors. It's also led us to develop marketing approach that not only attracts attention, but also sponsors could rely on us and trust our platform. At the same time, we understood that although we promote social impact, We operate with structured and value-driven model rather than as a nonprofit, of course, ensuring that all partnerships remain mutually beneficial and professionally aligned.
So our goal was not just to build a random car, but to create a high-performance one by changing structure of every component and checking key improvements in aerodynamics, drag reduction, micro-hardness durability. So every decision that was made by our team was strongly based on analysis of our past CAD models. We found AeroTune tool by Reddit connections from World Final Team that predicts the race performance based on our key properties. In just 1 month, we reduced our total racing time by 3 seconds, we reached around 2 seconds. And for the next super final in 2 weeks, we strive for 1.5 seconds to reach a world-class level. And we know what to do and what to improve. However, some of our key improvements are not shared publicly, as we prefer to keep them within our team. But our full process and development can be seen in our engineering portfolio.
So thanks for your attention, and if judges have some interesting questions that are mentioned in our portfolio, we are ready to answer them.
Okay, great. You have 4 minutes to answer the question. Your time goes now.
Okay, regarding marketing, it was good. So I have a lot of questions, but I let my technical colleagues to ask more because, yeah, they have really interesting marketing strategy.
Can you show us through the model of our car, please?
Of course.
Fusion?
Yeah, Fusion.
Okay, now, just wait a minute.
And how many iterations do you have? Like
Five iterations from worst to good.
Yeah, 5 iterations that actually apply to the STEM racing regulations. Actually, there are 7 of them, but 2 of them do not apply to STEM racing regulation. So there are 5 acceptable.
So here you can see the model of our final car. This is a G4 generation 4, and we did design it and did it in Fusion 300 or 360, and we can see it more professional in render. So how it looks.
Can you
This is
show
a final
downside of car?
downside here.
Okay.
There we can see the tether line that will be made out of aluminum, which is used to connect to the track race on STEM racing racetrack.
Okay. What techniques did you use to make a car?
We use a Fusion Autodesk 360, and also to test airflow and aerodynamics, we use ANSYS Discovery.
And for wheel development, as mentioned, we used FEA technique, which measures the durability of our wheels.
Can you show your analysis?
Analysis? Yep, in portfolio. Show them in portfolio. There one. Сейчас. Не надо. Okay. There is our wheel analysis, so you can read it right there.
What is your drag coefficient of your car?
It is regarding actually the velocity, it depends. So on the velocity that world final teams reach, it is 0.3.
No, drag coefficient, it's a stable, constant number of the aerodynamics of the car. Can you name of it? It's like a 0, maybe 35, maybe 0.18, maybe some kind of this.
Yeah, we just told you. It's like 0.3. And in AeroTune, our car reaches 2 seconds. So for a national final team, it is pretty good number, including the fact that our engineers mentioned that we strive to reach 1.5 seconds. So yeah, coefficient of drag is 0.3.
Can you show Fusion
Yes, we can.
iteration of your car model? How you say you make 5 iteration?
Yeah.
Can you show it?
So you can see the first model, G3, this is a more worse model. Then we have G4, our final model, depending on our test.
G4 open. Can you open G4?
G4?
Yeah, it is just the model that was opened right now.
Without color design. This is.
Okay.
Here we can see basic body, wheels, then we have
Your time is up. Thank you so much for the Orkin RT team.
Thank you.
Thank you. Have a good day.
Thank you. So now I'm inviting Furion team. Are they here? Furion team?
Yes, we're here.
Yes, hello.
Okay, I should give to Palina rights, right?
No, to Arjan, I guess.
Arjan. Okay. Okay, Arjan, can you share your screen now?
Yes. Is my screen visible?
Yeah, we see your screen. Great. Okay, your time for presentation goes now. Good luck.
Hello, everyone. We are the Furion team. I think you can all hear me. And today, only 3 of us will present it, Polina, Arjan, and Sanjar. Next slide. We are presenting IB and AS school and also Karaganda school, Morager. Our mission is to inspire other students who is interested in the STEM sphere to participate in such competitions as STEM racing. And our main values is openness and boldness, as we are presented as dragons. Furious. Next slide, please. So here you can see our visual identity. As you can see, we have 2 main colors, Bold Magenta and American Sapphire, which is included in every visuals of our team as a logo, car livery, and uniform. Our uniform and car livery also play a huge role into reaching out with our sponsors, as you can see, like in the center, we outlined places for gold sponsors, silver sponsors, and bronze sponsors. Uniform have the same structure. Next slide, please. So digital media strategy is very important for us, as it's very connected to the advertising and communicating with 3 our audiences, other teams, students in Kazakhstan and worldwide, and of course our sponsors. So LinkedIn is mostly used for like sponsorship. Also, we have our YouTube channel where we uploaded some tutorials on Fusion, as we are excited to help other teams when they like have some problems, like with some applications. And our main like result is the development of our Instagram, where the most of the posts are very informative about sustainability, like journals edition and other events we organized. Here you can see our benefits and ROI. So we divided into tangible, ROI, and intangible. So tangible is something that we can like quantify, such as like followers, engagement. So it's just like Instagram or TikTok analytics. Also, logo visibility may be measured like in the scale of the company logos on our visual parts. And intangible is our unique identity as a team, and also specificity of the sphere. So we're working in a STEM sphere. Yeah. We
Now
also
I would like
organized.
to. Yes, now to describe what kind of events we organized in terms of our outreach. So firstly, we have done several workshops and information sessions at different schools, including Nishastana IB and Comfort School, let's say 107. Also, we have made some useful relationships with foreign teams such as Nitro Racing and Mark One. They were very useful for giving us tips in the beginning of our journey. Also, we are partners with Orda Autism Center because Furion stands for accessibility and inclusion in STEM racing. So we have conducted presentations at the Autism Center, and we also helped organizing a meetup of different teams in Kazakhstan, which was one of a kind and the first type of that event. Then our current collaborations. First, as Paulina already said, we drink are official sponsors of Furion team. Then Earth Foundation is a US organization with 300 members focusing on ecology, and they are our partners for Qazaqstan and sustainability initiative. And as we have said, Orda Autism are also our partners with whom we promote inclusivity in STEM racing. Here you can see the final design of our CAD model. Our body is inspired by a teardrop shape because from our research we have gathered that it provides the least drag coefficient and it is most efficient in the aerodynamic perspective. Our rear wing and front wing have minimal and lightweight design that allows us to achieve effective downstream. Here you can see our manufacturing plan and that we considered several manufacturing challenges. We established a 5-stage manufacturing plan that includes using the balsa wood block, addressing underside geometry of the car, using ball end mills, and overall you can see the process here. Then this is about our future plans to complete and build the actual physical model. Then we are in current discussion of media partnership with F1 Kazakhstan, and we are also in a current discussion of sponsorship with Espresso Day and other
Your
brands.
time is up. I'm sorry for interrupting. So now you're having 4 minutes for Q&A. Your time goes now.
Okay, very good marketing presentation. So I think I will give more time to my colleagues from technical side of the jury, but marketing presentation is quite impressive. Thank you.
Thank you.
You say use CNC milling machine and balsa wood. Why you use wood for your car model?
Because it is lightweight and it is quite. 1 second, I can open. All right. Because first it is lightweight and it complies with standard regulations for the STEM racing, as well as it is quite suitable for the working with CNS machine.
Mhm. In your team, do you have the members who have before experience of using CNC milling process?
No, I don't think so. We don't have experience with this machine, sadly.
Do you have some kind of aerodynamic analysis or maybe structural analysis?
Yes, you can see it in our engineering portfolio that we have done analysis of our car body, but sadly we also encountered some problems with geometry of our car during the CFD analysis. Sanjar?
Hello everyone. So at the time when I'm coding the car model, I have some problems with my sim scale and ANSYS analysis because they have problems with inside geometry of bullet, and we attract to use AI just to imagine how the aerodynamics can leave our car. At the future, when we decide to change the whole car, we will use only ANSYS, not SimScale, because SimScale is too much hard with the inside geometrical.
Okay, one more question. What what main body part you choose the material of your main body part? It's a balsa wood or?
Yes, so we decided that we will use balsa wood for our main body, and we have also discussed what parts of our car we will either produce or buy. So the body will be done from the balsa wood block, and we will most likely source it from either Denford shop or Race to Learn, and we will also source the CO2 canister and the racing wheels from the same suppliers, because we have identified that in the cost perspective and in the production and materials, it is more effective to purchase them.
Thank you. Your time is up. I'm sorry for interrupting. Okay, thank you for the Furion team for that presentation. So now I'm giving the floor to Andrew Force team. Are you here, Andrew Force team? Enter Force team. Enter Force. We're not hear anything from them. Okay.
I will text Telegram chat. Maybe they are not here.
Okay. Okay, maybe someone joined now. Meet all. Okay, asking again. Enter Force team, are you here? Enter Force team.
Maybe we should go on to the next team.
Okay, I would go to the Integrum team. Integrum team, are you here? I think they're also not here, but maybe the team that couldn't present, I think Ogma team, or they're also not here. Enderforce, Ogma, or Integrum team, are you here? I don't see anyone. Okay, maybe we can take a break for 5 minutes. Then we will continue, especially for judges. So thank you.
Maybe 5-minute break we make. What do you think?
Yeah, we announced it, so we have 5 minutes break now. Okay.
Okay, hello, can you hear me?
Yes.
Yeah, we
Ah,
can
okay,
hear you.
I'll turn on my video.
Okay, should I give access to you? You're the Integrum.
Yeah, but not me. So Alimgir will connect right now.
Hello, can you give access to me? Please from there.
Alimgir. Oh, okay, just give me a second.
And also, can you give access to Smadhyar Paskar since he will present the CAD in the Q&A section?
Just give me a second. Okay, to whom to?
Smadhyar Paskar and Bakis Faringer.
Okay. Ansar Sagat Fried.
No, Smadhyarov Paskar.
Smadhyarov Paskar.
Smadhyarov. Okay.
Are you guys also in FCC?
Yes. What?
We're now in Houston.
Yo, congratulations.
Thank you.
Okay,
Camila,
can you
ready?
share your screen now?
Yeah, okay. Just give me a second.
Okay, let me know if you can.
Camila, are you here?
Yeah, she's here.
Okay. Is it
Okay,
visible?
your presentation time goes.
Oh, sorry. Just wait. It doesn't present it normal. Sorry.
Okay. Be a little bit faster.
And
Camila, are you here?
what? Why it's paused? Sorry.
Sorry, can you hear me?
Yeah, we can hear you.
Yes.
Okay.
Can we start?
So,
can we start now?
Yes, we can.
Okay, your time presentation goes
Yeah,
now.
sure.
Good luck.
Hello, degree members. We're Team Integrum. But why Integrum? Because we're integrating our engineer with passion. Let's head to our team. My name is Camila, and there are 3 people in our team who are responsible for engineering part. It's me, Arman, and Ansar. Askar is our designer, and Eliam is our enterprise manager. Let's our design philosophy. First of all, Integrum integrated in the same system to achieve one goal: to win final and to represent Kazakhstan. So we decided to choose purple, such an ordinary color, and blue and red are dominating in engineering because we want to stand out. And also we put our national identity items, and just like that, we're connecting our past, our history, and our vision for the future.
Okay, my name is Arman and I'm an engineer. Our car was built for one thing: straight line speed. On straight track, downforce is useless. Every bit of drag just slows us down. So our goal was simple: less drag, less friction, more speed. We focus on 4 things: drag, weight, rolling resistance, and mechanical friction. Total car weight only 55 grams. Our key innovation is closed-shape vortex generators at the rear. At high speed, air pressure builds up behind the car and pushes it back. Our vortex generators spin that slow air into vortices, pull fast air in, and shrink the wake behind the car. Result: 10% less total drag. And the faster we go, the more we gain because drag grows 4 times when speed doubles. But speed isn't just about power, it's about how we manage the air. Let's look at the specific aerodynamic solutions that make that possible.
I am Ansar. I am engineer. Teardrop body. Our design used a teardrop shape inspired by biomimicry, especially sharks and dolphins. It is a smooth laminar flow to achieve a lowest coefficient of drag. Next, rear wing stability. The rear wing is set at a minimum angle of attack. By using tail end plates, we reduced induced drag by 20%. Of course, we don't forget about virtual cargo. Inside layout design, theorists are one thing, but validation is another.
We run full CFD in sim scale at 20 meters per second. The underbody is already a major strain. Airflow accelerates under the floor and ground effect works as intended. The nose splits the flow cleanly with no front pressure buildup. Next steps: replace the rear wing with a flat zero-angle stabilizer, redesign the front wing with larger end plates to push air away from the front tires, and add a rear pentagon vortex system to reduce the wake.
And now let's talk about wheels. It's one of the most important parts of our car because we try to make the diameter as small as possible because the friction with the road will be as minimum. And also the weight of each wheel is approximately 7 grams, which is making the car more stable on the road. Also, we have made our improvement roadmap. First of all, in the next 3 months, we will change our wheels to the ceramic bearings so they will not wear off and the fraction will be even smaller. And also, we will place our vortex system in a pentagonal way so the stability will be even more high. Now let's go to the enterprise.
Hello, I'm Alem, Enterprise Manager of the team. First of all, we built more than 10 international connections with STEM racing teams worldwide, including national champions and world finals teams. We became media partners with F1 LA, one of the Kazakhstan's largest F1 communities, driving 130 new likes and 20 new followers, and partnered with Grader AI to reach ambitious local students. We're also exploring a partnership with Startup Kurs with more than 10K audience. We mentored Q Racing from NS Museum after hosting STEM racing masterclasses in 4 different schools, supporting them with CAD, engineering, and portfolio development. At the same time, we collaborated with professors from SDU who reviewed our CFD work and provided expert feedback on aerodynamics and drag optimization. This collaboration strengthened both our learning and impact, leading us to build a strong brand and major strategy to grow STEM racing in Kazakhstan.
I'm Oscar, and I'm designer in the team. A world-class car needs a world-class brand, and we built our with purpose. We started this collaboration through our Connect policy. We partnered with 8 international teams, gaining valuable insight from their years of the experience in just a few focused meetings. We then translate this knowledge into the strong digital preference. In just 2 weeks, our meta strategy generated over 30,000 impressions across TikTok, Instagram, and YouTube. Our focus wasn't just visibility, but value. From cat tutorials on YouTube to outreach on the Instagram and engaging content in the TikTok that involved our audience in the competition. To unify everything, we launched our website as a central hub for updates, contents, and future activities. Now, Alan will talk about sponsorship.
Our operations are supported with strategic partnerships with organizations such as NIS Schools, Aerospace, Polytech College, and Hoffman Aluminium. Here you can see our official memorandum with Aerospace, one of the largest educational STEM platforms in Kazakhstan. They will support us financially and provide access to their educational technologies. We also confirm support with Hoffman Aluminium, a leading custom profile manufacturer in our country. Their experience in production quality and industrial standards is valuable for us, and they're ready to provide access to our CNC machines in future foam cutting. At the same time, we're actively negotiating with Red Bull, Almat Hub, and Halyk Bank, who are interested in financial support if you qualify for the world stage. For sponsors, we created bronze, silver, and gold packages where each level offers different value, from logo placement and social media promotion to workshop co-branding and sponsor visibility in long-term community involvement. In return, we not offer only promotion. We create real value through STEM masterclasses, youth workshops, community building, internship opportunities, and knowledge sharing. As one of the first Kazakhstan teams developing STEM racing at this level, now Camila will talk about finances.
Sorry, your time is over. And now you have 4 minutes for Q&A. Your time for Q&A goes now.
Yep.
Guys, can you show us a 3D model of your car and how many versions do you have?
Yes.
3D model?
Yeah.
Okay, can I show you screenshots because the site will have work slow because of the CFD model is really oh wait. Okay, I'll show you the CFD.
How much iteration you make of your car model?
What's the translation of iteration?
Iteration, it's like you make first iteration, something not wrong, and you make second version.
As we said in our presentation, we had, for example, front wing versions and wheel system versions. So we in our portfolio, you can watch it later. We had 4 versions of our wheel system and 3 versions of our front wing. So in our portfolio, you can watch it more detailed. And here is the slides. For example, our wheel system from version 1 to version 4. Okay, so now I'll show you the screenshots of the CFD. Just give me 1 second. I also can show you the CAD model, all drawings.
Okay.
Can you see my screen?
No. Only your face.
Okay, right now?
Yeah.
Yes, we can see.
Okay, so here's our CAD model, as you can see. And why does it close? Okay, it has an accident closed. In our it's not in this computer, but in Figma we have our design of CFD screenshots. Just give it a second.
So one more question.
All CFD screenshots. So we'll like use sim scale to produce our CFD. So like force that's going on our bullet with the air velocity of 22 meters per second is 0.4 newtons. So here you can see first screenshots of the CFD. Also in our portfolio, you can see it later. We have other screenshots. For example, this one.
How you plan to produce this model? Or which technology you use and which material you use?
Okay, so we have a testing strategy. It will be produced by ABS 3D printing. ABS is like a very light type of plastic, and we'll use Gabilda bearing from FTC Details. Gabilda bearing, as you can see, here is our like wheel system, how we design wheels. Gabilda bearing, and also about manufacturing, you can see detailed in our portfolio. We'll printed ABS with infill 10%, and like we'll add additional surfaces for the better airflow because of the supports during 3D printing. Our model will not be like that ready for the airflow. So that's in our portfolio. Here's like paragraph about additional surfaces, how we like make the whole surface better.
Sorry, Arman. So Josh asked a question. What type of skills did you gain throughout the preparation? So the system of the
Sorry,
teams
your time is over for the Q&A.
Can I answer for the last question? Sorry, for the last question.
I don't think
You can
so.
write in the chat.
You can write in chat
Okay.
maybe, but because
Okay,
we
thank you.
need to give the time for another team. Okay, please,
Thank you.
Iron Nomads team.
Thank you. Goodbye.
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 Thank you. Goodbye.
Bye. Okay, Iron Nomads team.
Good luck
to
on
whom I
first.
should give permission. Okay, I see you. Okay, can you share your screen? Iron Nomads, can you share your screen?
Hello, do you hear us?
Yeah, we hear you. But I
We
think
don't
you
hear
should...
you, unfortunately.
You don't hear me? Now, do you hear?
We don't hear you. We tried to leave the conference and come again, but we still don't hear you.
I don't know what's the problem.
Maybe you have headphones.
Okay, let's try again. Iron Nomads, do you hear us?
Yeah.
Okay, do you hear now?
Mm-hmm.
Okay, can you share your screen? Can you share your screen?
We shared it. Can you see us?
We see you, but we don't see your presentation. So please be a little bit faster.
Трансляцию экрана сделать. Покажи. А как сказать? Курсич.
Guys, can you share your presentation?
Экран телефона вот так покажи. Так не видно же все равно. We cannot. There is something. It says that organizer.
Okay, what's your another name?
What?
What's
Another
your
name?
username in the Zoom?
Iron Nomans.
I gave the permission.
And Binom Ilias.
Binom Ilias, it's yours,
Yeah.
right? Okay.
Yeah.
Okay, can you share it now? Okay, now we see your screen. Okay, so you have 6 minutes to present. Your time goes now. Good luck.
Today we're going to represent our car based on Formula One design. First of all, the design conception and engineering overview. Well, if we talk about the design objectives, it's our goal to minimize the aerodynamic drag and ensure smooth and ensure the smooth airflow quality of the car is, and our design is followed to focus on the smooth and continuous shapes of the car. Next. Our design process started with hand-drawn sketches where we explored different body shapes and aerodynamic concepts. We focused on creating a smooth, low-drag form with efficient airflow distribution. This is the first sketches of our car from the front, above, and the right side of the car. Next. Engineering principles. If we look on the car from above and the behind side, we can see the reaction force and weight, which is force due to gravity acting, friction force, and driving force, for example, thrust. Next. Aerodynamics. Aerodynamics plays a crucial role in the car's performance by controlling how air flows around the body. The car features a streamlined and compact body designed to reduce aerodynamic drag and improve airflow efficiency. Aeroelasticity. Structure and components of the car. So in our car, we can see the wheel system, front wing structure, and our car is built with a strong and lightweight structure to ensure the durability and performance of it. Next. Alternative testing and analysis. We don't have set program, so we limited access to simulation tools. Our team conducted qualitative aerodynamic analysis based on testing principles.
we evaluated airflow direction based on body shape and drag reduction features, smooth surface, and curved edges.
As a conclusion, we wanted to say about the final evaluation. So this project helped us to develop skills in engineering design, like designing the Formula One based car, aerodynamics thinking, and teamwork. We also gained experience in simulation tools and data-driven decision making.
That's all, and can you wait? We will show you the second presentation with the team now.
So this is the So this is the enterprise portfolio of our team. First of all, we wanted to talk about the team identity.
Next.
Who are we? We are Team Iron Nomads, and our logo is shaped like a shield, which symbolizes the protection, friendly and supportive community. Next.
Team structure. Our team is organized into clear roles to ensure an efficient workflow. Our first one is team manager, coordinates the team, testing analyst manager, conducts simulation and analyze performance. And the main speaker is responsible for presenting the project and clearly explaining our work and result. Design engineer responsible for the car design and set modeling. And manufacturing engineering works on building and assembling the car. And last one, graphic engineer, graphic designer, and creates the portfolio and presentation. Next.
The project idea of our team. Our project focuses on designing the car and aiming performance by testing different shapes, materials, and aerodynamics features to reduce air resistance. Next.
This is a technical drawing of a Formula One car created
Sorry,
in the
your
style of
time
engineering.
for presentation is over. So now you have 4 minutes for Q&A. Your time goes now.
Girls, you know this competition rules. You need to make small model, not big model.
Sorry, we can't
like a car.
hear you.
Girls, do you hear me?
No.
Do you have any 3D model of your car, like in Fusion, Autodesk? I don't know what. I don't know what. Do you hear me?
Аржан, скажи им чат прочитать. В Телеграме можешь написать?
Не слышат This is the 3D model of our car. We cannot hear you, unfortunately.
Можешь им в Телеграме, может быть, написать?
We can't hear you.
Wait. Did you make this model by yourselves? Yes, our 3D design manager made it by himself in the Blender. Yes. We will produce and manufacture it by designing developing the design alternative testing. We manifest our idea by transforming it into physical design and more.
So I think if they cannot hear our questions, we can move to the next team.
Okay, so I
all.
think.
Thank you for your questions.
Okay, great. Great. We are moving to the next team. So our next team
We cannot hear
is.
you.
Okay, they cannot hear.
Hello?
Okay.
Just give me a second.
Okay, bye. Thank you for all.
Bye. Okay, Iron Elements. Okay, the next team is CS for speed.
Yes.
To whom should I give?
Me.
Okay, I would give permission. Just a second.
Hello.
Okay, can you share screen? Hi. Can you share
Yeah.
your screen?
I can't share my screen right now.
You can?
I can't.
I gave you permission.
I'm in. Oh, here.
You can, right?
Yeah, it's okay now.
Okay. Should I give to anyone else or okay?
No. It's okay.
Okay,
Also,
now you're what?
I have a question. Is it okay if I show my design like this because on my bigger computer I can't open Zoom?
I think that would be fine for judges. It depends on them.
All right.
They would write. Okay. So you have 6 minutes to present. Your time goes now.
All right. We're the team C's for speed. Aitik, Alibek, Amerbek, and Nursem Mansour. So I'll go ahead and show the team. I'm the captain. My name is Shandal Aitik, and my teammates are Amerbek Onaev, Alibek Irsen, and Mansour Aysen. All of my teammates have years of experience. For example, me and Dalibek have actually won the Republican Olympiad in physics. We made a research paper on on working on aerodynamic profiles of wind turbines, and we made CFD modeling. So I think that shows our expertise. And for example, Ursen and Mansour already made their non-profits, and actually Mansour is right now went ahead and went to Launch Cheeks and is going into the summer to San Diego. And Amerbek Knife is a Olympiad finalist in the national Olympiad and got the third place in all subjects. So I'll go ahead and tell you about the design, specific design elements. So tapered nose, the narrow pointed from splits, the air with minimal disturbance, directing it precisely to the suspension zone and side pods. The halo cockpit. Even the safety structure of the hoop above the driver is shaped to minimize its impact in the air. So what did we do in our design? We eliminated the vacuum effect. One of our most critical design concepts is the tapered tail. If our car ended flat or blunt shape, it would create a low pressure zone behind us. This would act like a vacuum, literally pulling us backward. Now, and we optimize every surface, every curve on our orange shell is intentional from the side pod channels that use the Coanda effect to keep air attached to the slim profile that reduce resistance. We have designed visible light to be a ghost on the track, slipping through the air with as much momentum as possible. Should I show the 3D model? Okay. Albek, you can go ahead and talk
Okay,
about
so
analysis.
let's just move on into analysis. So as we can see in the first graph just above the text, so by this graph we can understand that our performance data reveal how our bolide interacts with air during a high-speed run. So the first graph displays the pressure coefficient, the CP value along our car's length. So where we see a significant pressure spike at the nose as we first hit the air, followed by fluctuations that show how the air accelerates over our body curves. So these peaks and valleys help us identify the areas where the air might be pushing against our forward motion or creating a beneficial low pressure zones. And so the second graph at the left side of, uh, of the presentation summarize the resulting aerodynamic forces at the different axes. Showing our primary challenge is the 5.96 Newton drag on the Z axis, which is acting against us. So, and we have successfully minimized our side force, the force at the x axis, to negligible 0.01 Newton, ensuring we track perfectly straight without wobbling. Like we're just gonna go straight without any uh, wobbling. So meanwhile, our downforce and the force at the y-axis sits at 1.74 newtons, which provides just enough stability to keep our wheels grounded without creating excessive friction that would bleed away our momentum. Together, these metrics prove our design is highly efficient for a straight line sprint.
Okay, so how do we actually plan to spread it out, spread our cars and our brands? So first of all, we are planning to do a market dominance. So we will establish CS4Speed as the premier brand in the racing community, leveraging high prestige association with different persons. Also, we will plan to make a PR company, like we will we will find our target audience through Instagram, TikTok to maximize our return on investment. So basically, if we will gain a lot of customers and a lot of funds for our team, so we can sell merch and other stuff like this to them. And the star strategy. So we will recruit the most charismatic and the most beautiful students as our ambassador. So he will capture the attention of the female demographic to expand the fan base, and he will host
high energy booth to drive merchandise sales. So this is our plan.
So let's talk about sponsorship as previously we know the Fab Lab and the All Education Foundation also sponsored before sponsored us in our competitions in our hackathon. So we have some sponsorship beforehand. Like Fab Lab is powered by Nazarbayev University Nouris, and so we have some sponsors in there. So also our school have sponsored.
Sorry, your time for presentation is up. You have 4 minutes to answer the Q&A session. Good luck with that. Your Q&A session goes now.
All right.
Okay, I have a question.
Yeah.
Guys, how did you make sure that your model will fit within the stem racing dimensional constraints?
Well, actually, we looked at the regulations and we will. Oh, do you mean on the map when we'll send out our car?
Yeah, when you manufacture it, I mean.
Oh, when we'll manufacture it, actually, we already, me and Dalibek have already went through the internship at Fab Lab, and we're allowed to go anytime we please, and we are going to use their 3D printers and other accessible properties for our car. Yeah, that's how we're manufacture it. We already have enough money and SC, PDL PDL 3D printing stuff. Yeah.
Did you count how much it cost your model?
Well, we didn't count how much it would cost, but basically, if I put my base on like if I looked at last models, like they're kind of small. I don't think it'll cost a lot. Yeah.
Do you make some kind of analysis, structural, maybe aerodynamic?
Yeah, aerodynamic. So I didn't have enough time to make the CFD modeling because my school wouldn't give it out. Last time, Fab Lab gave me access to their CFD Ultimate by Fusion. Uh, we made analysis through Python by NumPy, and we made like a 3D boundaries in a box, and it gave out a few graphs like power coefficient and lift drag coefficients.
And what is the parameter of the drag efficiency?
Drag coefficient. Let me look at my presentation. Drag coef. 1 minute. Can I? It's in a different place. Don't think they added it here.
Okay, so far you're looking for this information. Do you have any strategy for sponsors, or you have only ideas how to do it?
No, actually,
Oh,
we have sponsors. Oh, Mansur can
I
can
can
say
answer this question.
about it.
So basically, we have a sponsor as a Porsche because our school actually held uh, like an event with Porsche sponsorship. So basically, we went there and they gave us money to build and to create an art event in our school. So also we have the Ulutau Foundation. So they will give us the exact amount of money that we need to prepare our product at the final stage. And FabLab and Nanu, as Shintasaituk said. So yeah, we have a lot of sponsors that will help us to maintain our product.
So all of the sponsors are here are already sponsored us in before other events.
So time for Q&A is over. Thank you so much for the team for your presentation. And now I'm inviting the team STEM Shop Accuracing.
Can I say my last thing? I found the drag coefficient Who can I send it to? Like after?
It's I think the question to judges. They would answer, but I'm searching for the STEM shop accuracy. Are you
Can you
here?
give us rights to present?
Okay.
Oh, Aku is a word.
I take your question. You can ask in the chat or in the Telegram. It would be better because here we are having presentation.
All right.
I gave
Thank
the
you.
rights. IQ STEM shop accuracy team. Can you share your screen? We should check it
Yeah.
out. Okay. So
Okay.
now you're.
You see it?
Yes, you're ready.
Yeah, we are ready.
Okay, your presentation.
Wait a second, please. Wait a second. Our
Okay,
internet
please be faster.
When
Please, guys, be a little bit faster as we need to move with other teams as well. Guys?
we have some technical issues. Wait a second.
Okay. But be a little bit faster, please. STEM shop accuracy team. Are you here?
Yeah, we are here.
Can I do it a bit faster because we're running out of time?
Yes, we are running out of time. Please, I will start counting your presentation time now. Okay, so I think it would be
We are
fair.
ready. We are ready.
Okay. Your presentation time goes now. Good luck.
Hello, dear judges. Welcome to the Aku Racing Team. Start off, my name is Nariman and I have the role of team lead. So, why Aku? In the Kazakh language, Aku means swan, and we choose this name for three fundamental reasons. Unbreakable synergy. Swans are known for their lifelong loyalty and partnership. National identity. We are proud to represent Kazakhstan. By bringing a Kazakh name to the global stage, we aim to showcase the innovation and engineering potential of our country to the international STEM community. Aerodynamic excellence. This one is one of nature's most aerodynamically efficient creatures. It's sleek, graceful, fully inspired from our design philosophy.
Hi everyone, I'm Hamjan, the enterprise manager. So what makes the Apple brand stand out? It comes down to three things. First, our symbol. Apple means when in Kazakh. We had designed it with smooth curves to represent laminar airflow, showing that we bridge the gap between nature and engineering. Second, our look. We use Aero Pink and White. It's a bold, strategic choice that makes us impossible to miss for judges and fans on the track. And finally, consistency. From our cars livery to our uniforms, we keep everything unified. It shows we are a professional, high-level team with a clear vision. That's what we identify our crew. Thanks.
My name is Atman. I'm a social media manager. So we use Instagram accuracy to build our brand and share our engineer journey. Through posts, insight, and partner highlights, we connect our sponsors with the STEAM community and promote Amadeus talent worldwide. Our title sponsor, Steam Shop, provides and funding the materials that make our project possible. Our technical partner, Raceplace, supports us with the simulation and texting, helping us improve performance. We also collaborate with Amata Ahmad and Amata Darna, who support your education and help us represent our city. Together, this partnership drive our growth, allow us to compete internationally and inspire future engineers.
Also, we launched two websites that I'm going to show you right now. Here's our main site. Do you see? That's like here we have everything about our team and our engineering process. And second site is about like lights out, reaction test. So this is our first year. Also, it's Kazakhstan's first year in STEM racing. So we even didn't know about this competition before. So we started our ideation development. Our ideation development was fueled by a blend of aerospace technology and nature. We drew inspirations from F-22 Raptor, supersonic efficiency, and the boxfish natural stability, combining them with the Formula E Gen 1 wing designs to define our initial aerodynamic silhouette. In concept development, we progressed through three key stages of evolution. Preliminary analysis, we started with basic geometry to establish our baseline for penetration. Aerodynamic refinement. In iteration 2, we introduced a 5-degree angle of attack and taped the nose, but discovered critical windsweep vortices. And in final design, we solved these issues by integrating structural endpoints and perfecting the surface finish. Here is our CAD drawn wings of our car. We were inspired by swan designs that gradually increase in section, reducing the drag and boosting downforce, wheel ramps, and stability at speed. Our body narrow, teardrop but boxy shaped with a boxy inspired underpanel for smooth airflow and high speed stability. Wheelbase, lightweight, biometric structure inspired by bird bones. Special bearings cut friction by 78%. And manufacturing. Wings are being made from CNC machinery, but wheelbases and main body is being printed by 3D printer and also being being made glossy and slippery in the air with the acetone vapor with us.
Hello, I am Shapagat and I am the product manager and I also do SFT analysis and I will show you results of the analysis. This report covers a full SFT analysis of the STEM racing car across 6 modules, drag, friction, noise, pressure, and both exterior and underbody airflow. The core takeaway is that this car is built around
Your time is over for presentation. So now you have 4 minutes for a Q&A session, and the time for Q&A goes now.
Okay. Did you carry out any CFD simulations?
Which?
CFD simulation. Can you
CFD,
tell us
yeah.
more about why?
Let me show you. We used air shaper. We had a problem with every other CFD programs like ANSYS. So because we made our Halo pod a bit smaller, so Halo could get in easily, and so we decided to use air shaper to make the CFD analysis, but we also bought the use number for it.
Okay, and what
Can you
sources do you use when researching your car design?
Huh?
What sources did you use in making your car design?
So sources.
Yeah, like what did you research?
Откуда вы брали данные?
So in our team history starts in 2025. Like in the 2025, I was in the
Какие исследования вы использовали или данные материалы для создания машинки? То есть какие сайты, там еще что-то, то есть sources.
So we watched the tutorial from YouTube. We also we used AI, but we got input by ourselves. AI just got us some tips.
How much is your drag coefficient?
Drag coefficient.
Drag coefficient is used in a formula of drag force and downforce. We take it as 0.7. We can take other numbers, but we choose this.
How much iteration you make of your 3D model?
We made 3 iterations of our model.
What AI you used?
Gemini 3.1 Pro and Cloud Opus. We wrote it right here in verification log assistance.
Can you show us a 3D model of your car?
So this notebook doesn't have any fusion, so we converted it into the on-shape.
Can you show downside? No. Down. Низ. Okay.
That's all.
What software did you use? Fusion, you said? Yeah, for making model.
We use Fusion 360.
Okay.
I don't have question.
Do you have any experience in CNC machines? Like
Actually,
Hori?
no. Even if we pass this.
Sorry for interrupting, but time for Q&A is up.
Okay,
Thank you,
guys.
for that team for your presentation. So now we are moving to the team John, who is the representative. Can you please say your username? John team. Okay. Team John, are you here?
Hello?
Yes.
Hello, everyone.
Okay, I should give access to Rina, right?
I need to demonstrate this. We are one lead. Hello, we are one lead team. Can you present us?
Okay, can you share your screen? Who is the John team?
One of them.
Okay, I'm sorry. Should I give to Ju? Okay, I gave access to both of them.
Great. And quality.
Can you hear as well?
Yes. Can you share your screen?
Yes.
Okay. Please be a little bit faster as we need to move with other teams as well. Okay, your time for presentation goes now. Good luck.
Okay, so let me first start with the team structure. Each member has a defined role. First member, Turat Mukdawlet, who works as a lead CAD engineer, responsible for the main 3D concept, engineering structure, aerodynamic layout, and core vehicle geometry. Raylam leads manufacturing and operations. I lead branding, communication, social media, and presentation. Our first member, Alisher, works on CAD optimization, technical accuracy, and preparation for manufacturing and testing. This role distribution helps us avoid confusion and makes every person responsible for a specific part of the project. These roles are clearly presented in our team section. Now, our branding. We did not want John to be just another racing name. We built our brand around a kind of meaning: soul, fire, energy, precision, and competitive spirit. Red represents speed, energy, and passion. Black represents strength, precision, and technical depth. White adds clarity and balance. Our Instagram and visual identity were created to make the project recognizable, not only functional. This branding logic is explained in the branding section of our portfolio.
So let's talk about our partnership and sponsorship. So first partner is Salem Social Media. It is a Kazakhstan media company with the largest content producers in Central Asia. And it has its own network of online channels for different ages. And it has produced more than 150 projects, including 73 web series and 5 feature films. For Jan Racing, Salem Entertainment is a valuable partner in media production, storytelling, promotion, and increasing team visibility. Here you can see how we met with Salem, with their producers and directors, what they told about us, and how we maintained a good meeting with them. Our next partner is the GNL Racing Team Media Partnership. It's a partner of Sokol Raceway, and it's a Kazakhstan karting and the motorsport organization. It supports young drivers and karting community. And here you can see how we are planning our next meeting with them, which will happen in a few days. Also, we received expert feedback from an engineer at Kaz Rockets. And also, our next marketing and sponsorship strategy is Yala Racing Media Partners. It's one of the leading organizations in the CIS region, recognized for its advanced racing simulations, professional level equipment, and immersive motorsport experience. It's going to give us $4,000 for our next development. Here you can see the video we shoot, and Yala Racing also agreed to offer access to racing simulators for driver training, open to allowing the track for race events in the future, and provide us opportunity to use the track for preparation and practice for the STEM racing competition. And here you can see a STEM racing development webinar that was held across 3 countries, Kazakhstan, Kyrgyzstan, and Tajikistan, with more than 80 people. And here you can see the interview with champions we made today. You can later. Thank you for listening.
Alisher, you can start.
Hello, my name is Alisher, and now I'm gonna talk about our car's design. So the first design wasn't actually very good. The main body had sharper transitions after we made it smoother and more taper to reduce pressure drag and improve airflow over the car. Same as wheels, the wheels area looks less interacted. After we cleaned the axle and supported geometry to reduce unnecessary turbulence around the exposed wheels, and rear wing and front wing were very basic and simple. That's why the downforce wasn't actually good enough. So that's why we changed it to more complex, and it gave us more drag wheel or drag force. Uh, Side elements, before the elements looked mostly decorative, and now they aren't very sharp. They are guide to
airflow along the lower body and improve visual and aerodynamics balance. That's it.
Thank you for your attention. We're ready to answer your questions.
We also created the Telegram bot for sending news about sim racing and website where you can test your model and yeah,
Can you
so
demonstrate
without
your website?
website. Okay.
What kind of software do you use to making your 3D model?
Fusion 360.
Can you open your 3D model?
Okay.
And you said about aerodynamics, you make some kind of analysis.
CFD, yeah.
Can you show it too?
No, Nordorет.
Okay, now we're gonna show you our site. Our and after yes.
Okay, типа, we
Regarding marketing part, guys and girls.
Your presentation time is over. Now you have time for your Q&A, which goes now.
Okay, thank you.
Regarding marketing part, guys and girls, it's very good. So I'm impressed. So I let my partners to ask you more questions about the technical side because you more made the sponsorship and marketing presentation. Very good. So I'll let them to talk to you.
Can you
Okay,
give access to share the screen, please? I'll show the CAD.
Покажи access. Алишер access.
I gave you.
Yeah, give it.
I gave you the permission, so you can do it now. Lisher.
Here it is.
How much iteration you make of 3D model or your car?
How much of what?
Iteration.
Iteration? Like what?
This
Like
is your
price
first
and
model or third or maybe fourth?
Yeah, how many versions of car did you make?
No, two versions. No, yeah. Actually, 3 versions. This is more detailed second version.
Yeah, what sources did you use like to change your car? Like why did you change it?
To make it more smooth, you know, like all these angles were very sharp and didn't give us as much aerodynamics as it's supposed to give us.
Can you show backside?
Website?
Yeah.
Backside.
Thank you, thank you.
Guys, what is drag force and how it affected like in making your car design?
Not drag force, like wanted to say the downforce.
No. Drag coefficient.
Drag coefficient is our drag coefficient is about 0.4. Yeah. It's like this area, right?
Yeah, can you show analysis? You say that you got an analysis about the aerodynamics.
Analysis.
Did you make any CFD simulations?
We did CFD simulations, but they're half ready, and we cannot show it to you right now because
We created the airbox and tried to.
What kind of software did you use?
I used ANSYS, Fluent, and ANSYS platform. No, not app. Also, I use sim website for, I forgot the name, sim checker. Or
What about manufacturing? Do you have a plan of the manufacturing this car? How do you make it?
Yes, we already had a meeting with our school. We study in this private school, and our school is ready to be as a sponsor and pay for all the materials and
No,
the
not
3D
sponsoring.
printers.
I want to ask methods of the manufacturing. How do you will manufacture it?
Sorry, but
What equipment do you
time.
use?
Sorry for interrupting, but
Ask
time for
in chat.
Q&A is over. Write your answers in the chat. So we are moving to
Okay.
another team. Thank you so much for
Thank you. Thank you
presentation.
for your
So
attention. Bye.
the other team is Q and Lip. Okay, Q and Lip, are you here?
Yes, we hear.
It's Rina K. I should give access to you,
yes.
right?
Yes, we are.
Okay, I gave you access. Can you share the presentation?
We have 3 accounts in the zones.
Okay,
Can
what's
we
the another account?
inform with them?
No, we have it here, so they're
So how are you gonna share your screen?
We can open only them.
What's your another account? Could you say the name?
leave them.
One, leave them.
See.
Can't leave them. Okay. I gave you the access. Can you do it now?
Yes, let us try. Oh,
Wait.
yes, so.
I see you can do it. Just give me okay. So now you have 6 minutes to present. Your time goes now. Good luck.
Good morning. We are One Lead Team, and here we're presenting our car project. We're glad to be here and present our team on this international competition. So now let us start with performing our team identity. Our team qualifies Qazaqstan and international STEM racing competitions. Our goal is to showcase the country's technological advancement and potential on the global stage. The team's names evoke the concept of quantum leap, a dramatic shift to a new level. The team colors blue and purple simulate science and innovation. We embody the idea of speed, power, and exploration. Our team doesn't simply create a muscle car, we demonstrate the transition to a new generation of technology and design. Our team is more than just a group of people, but a well-coordinated mechanism. We work through mutual understanding, support, and shared goals. This approach allows us to effectively solve problems and achieve results. Let me now introduce our team members. My name is Amina. I'm a singer.
Hello, I'm David Kirov. I'm an engineer and modeler.
Hello, my name is Etienne Karina, and I'm the organization manager. Good morning, my name is Leonora. I'm the project manager.
Hello, my name is Ahmed Garif Milan. I'm the engineer.
Our team began in 2025 as Nova and competed in the CLL competition, where it won an award for its innovative project. In 2026, we transitioned to STEM racing and created Quandy. We are certainly continue to develop the project and improve our cars. We work in stage from setting goals and studying the rules of project testing and the final implementation. The main goal are to create a fast and stable car, prepare the mechanism, and successfully pass the selection process.
The majority of the budget, 55%, goes toward vehicle development. Other costs include registration, team uniforms, custom duties, and other expenses. 3D printing plastic plays a crucial role as a multiply prototypes as required.
We are promoting the project in Instagram, building a recognizable brand. We are supported by a school and a robotic class. In the future, we plan to expand our sponsorship networks and collaborate with some businesses.
We choose blue and purple because they evoke association with technology and the future. Blue symbolizes robustity and connection to Kazakhstan, while purple represents innovation and differentiation from other teams. Together, their colors make all design memorable and emphasize the idea of technology in the breakthroughs.
The main components, the front wing, underbody, and diffuser, generate downforce. This helps the car maintain stability and speed on the track.
The entire model was inspired by the car competing in the London 2025 Grand Prix driven by Max Verstappen and Liam Lawson. I'll start with the front spoiler and the streaked shape. The side section are designed to reduce the drag on the car's wheels. The main part of the spoiler designed to direct airflow around the outside of the car. The body of the car is modeled after the famous F-22 fighter jet. According to analysis, the body has been weighted towards the wheels to reduce drag. And both of the body has rounded section to reduce contact patch with the reduce the car weight.
Yeah.
We analyze air resistance, drag coefficient, and downforce. Optimizing the parameters allows us to increase the vehicle speed and handling.
Our project is a combination of engineering, design, and teamwork. We've created more than just a model, but a well-thought and competitive product. QuantLeap reflects our approach and commitment to innovation and reaching new heights. This is just beginning, and we plan to continue to grow and represent Kazakhstan even more strongly.
We're ready for questions.
Okay, great. So now, Tam, your Q&A time will start now.
Yes. So maybe here's the first question.
You say about the drag coefficient, which number?
Can you repeat, please?
You say before you make CFD analysis, drag coefficient, and which number of your drag coefficient?
Which
Percent.
Процент угла падения какой?
45 less, maybe.
About 45.
Okay, guys.
How you
did-
manufacture your car?
Can you repeat?
How you will manufacture your car?
Fraction.
Как мы будем производить?
In CPU is material is balsa. We can mainly special made in special weights and
just we'll use special GPU with the material balsa, so we'll do it with it.
And software we use in Autodesk Fusion.
Okay. Did you research any real racing cars before designing yours?
Can you repeat?
Did you research any real racing cars before designing yours?
Yeah, we said about it. We research Max Verstappen's cars and
And
cars.
awesome.
Yeah, very awesome cars.
Yeah. What did you look at when you design yours?
On these two cars.
Looking for the best, just like front wing and wing and spoiler. Also, we take some of the shapes form to fit in parameters and increase the speed.
Do you have before using CNC milling process? You say you produce this car with balsa material using the CPU CNC milling process. Do you have the before experience of using this process?
Yes, of course. Yes, of course we have.
No, but it's too little experience about these systems and
What you make of using this technology CNC? What you make?
we made a failure model of car, but we already fixed it with our new engineers. The first model was a failure, so we changed it a bit, the model, and now
Вы
we...
раньше работали с ЧПУ станком?
Да, да,
Yes,
yes.
but it's for...
Of course.
Okay, regarding your sponsorship strategy, do you have a structure how you approach sponsors with your offer, with maybe some package for them?
Sorry for interrupting, but the time for the Q&A is up. You can write your answer about the sponsorship in the chat, and the question also can be written here. Thank you so much. Now I'm
Thank
moving
you.
to the team.
Okay, thank you.
Thank you.
Okay, there should be another team. Irbis is, if I'm not mistaken. Irbis, are you here?
Yes.
Okay. Yersin, I should give access to you, right?
Yes.
Okay, I gave it. Could you share your screen?
One second, please.
Okay, please be a little bit faster.
Okay.
Okay, your presentation time will start now. Good luck.
Okay. Hello, dear judges. We are team from Kazakhstan, and we very excited to be here today. We are taking part in this STEM racing for the first time, and for us, it is a very important experience. Our main goal is not only to make a fast car, but to get high points in all parts of the competition: design, engineering, and teamwork. Now we would like to talk about our car decision. We try to make our car simply, light and faster. Uh, we try to make our car simply, light, and fast. We understand that aerodynamics is very important, so we work on the shape of the car or reduce air station. We tested different ideas and chose the best one. We also paid attention so small details because even small change can make a big difference. How we can you see this car like a prototype? It's not a finished variant. We have a lot of another variants. For example, we have on Fusion. First one was like this. It was more simply, but we think that it not be very interesting and aerodynamic. So we working for this car and made more like more professional version of this car. We think about that this car will be more uh, for like in internet we have a lot of like this models and things that it not will be good for choosing this one. So we make that one.
Next, about our teamwork. In our team, every member has a role. We have clear responsibilities, and everyone knows that to do. We always support each other and work together. When we have problems, we discuss them and find solution as a team. Good communication helped us work faster and better.
Portfolio work process. Now about our portfolio and work process. We carefully followed all the rules in the requirements. We planned our work step by step and used our time wisely. During the project, we improved our ideas and learned from our mistakes. We focused on quality and tried to make everything and well organized.
During this project, we learning many new skills. For example, teamwork, English communication, time management, design, and what? This experience is very useful for future, for our future. In conclusion, steam racing is not only about speed, it's about creativity, teamwork, and learning new things.
In our work, we can say that we work a lot. For example, we don't make like one work. We make a lot of. For example, we go to another Olympics. For example, first we they in the in our FLL we show our projects and work more like for project and etc. So we can say that we our know about this our work. We can say and understand that. Also, uh, uh, and okay, we say that about our car. The first is body. The body is the main structural part holding the CO2 cartridge and ballast. It supports the structure, shapes aerodynamics, and describes weight, its experience impacts vibrations and air resistance. A weak body may crack or deform. Non-course assembly, the front part of including the nose, front wings, and in the planes. It directs airflow, reduces draw, and improves stability. The here wing assembly is an aerodynamics element at the back. It stabilizes airflow and reduces turbulence, and it is exploded to air pressure and vibrations and may bend its if were weak. Front wheel support system include from the wheels and mounts if it control movement and directions. Here wheel support system carries most of the load and helps as accelerators experience strong forces during launch and braking can jam or brake if poorly designed. From the line guide, keeps the car aligned towards the line.
Time is
Experience
up for the presentation. You have 4 minutes to answer Q&A.
Alexei, can you turn off? Yeah. Can you open the Fusion? And you see your timeline and on the starting, can you move your timeline on the start of your 3D model? No. In downside, you have timeline. You see? Yeah, and can you move your last position to the start?
On your left side, you have a small stick to
Можешь
the
вот эту
left.
маленькую черную палочку передвинуть в самое начало? Да. Ага. Дальше не двигается? Это все? Окей, хорошо.
That's it.
Окей. Эм,
What materials do you use to create your automotive machine?
We chose like what kind of plastic for our cars. I don't remember what this in English.
Yeah, you can say a name of the plastic in English, if is it plastic, and how you will manufacture it. What kind of technology do you use?
Also, we use wells, strong wells, because we we have cons very strong concentrations and a lot of time driving in karting.
Approximately, say technology, what the kind of technology, how you will manufacture this car. Will you cut it, maybe use laser or some kind of technology?
Maybe 3D printing. What type of technology you use for making this car real car?
In the
Model
end
car.
of the event, you will make a small car, and you should know how to make it because the team that make how to say make a correct road or map of making from the idea to the final prototype will win it. So you should know.
At the time, we don't doing like in 3D for and make it. We more working for 3D programs, for example, Fusion to make it, but we don't print it like for 3D printer and put it.
You don't
Как вы
understand.
сделаете эти машинки, произведете? Короче, какую технологию вы будете использовать, чтобы сделать эти машинки?
We use the 3D printer.
Which material you use for printing?
We use light materials, CNC machine, and CO2 cartridge.
Sorry, your time for Q&A is over, so we are moving to the next team. And our
Can
next team,
we show one slide in presentation
Okay.
with sponsorship?
No, with sponsorship, no. And one last question: why do you use Revit for making 3D model?
Revit.
maybe you could answer in the chat.
Yeah, answer in the chat.
Yeah, that would be great. Okay,
Yes.
cool. So now we're moving to the Ogma team. Could you please say your username? To whom should I give access?
Hello, can you hear me?
Yeah, I can hear you. So
I'm from
Anastasia.
Team Ogma. Yes, I need the
Okay, I'm
access.
giving you access. Can you share? Can you share the screen?
1 second, we'll check.
Okay, great.
Can you see it?
No, we cannot see it.
1 second. Can you see it now?
Yep, we see that you share screen, yes. Okay, so you have
so-
6 minutes to present. Your time will go now.
Hello everyone, we're Team Ogma. Quick check if you're still awake. It's great. If not, perfect timing because we brought some knowledge with us. Our mission is to make STEM racing and mechanical engineering skills accessible across Kazakhstan and Central Asia. Here you can see our team, and we have two sub-teams, engineering and enterprise. Now, my
hello.
team doesn't continue.
Hello, my name is Azamat. So let's start with the team journey. Our team journey started from different engineering backgrounds. Some of us had experience in shuttle marathon, others came from robotics or maybe science hub projects. This gave us a strong mix of practical building, coding, research, and presentational skills. Like, for example, for me, the experience I gained as a shuttle marathon significantly influenced many aspects of my life, including STEM racing. After spending nights searching for documentation on the Chinese braking system in Qatar, it became much easier for me to find different sources and instantly assess their value and credibility, which helped me to develop research development and STEM racing. So, Anastasia?
I'm the cut engineer of our team and engineering head, so I'll tell you about our versions. We had actually three versions. The first one looked like this. It had flat rear wings and a front wing with simple flat elements and quite narrow body panels. As a result, flat rear wings did not create enough control downforce, as you can see from our CFD, and exposed wheels created turbulent airflow. It also increased the drag from, as we know from our simulations. So we made the second version. We changed the flat wing to slightly curved and enclosed rear wing. You can see it here. And as a result, a curved wing can guide the air more smoothly than a flat plate, and it also increased the stability. Also, we made an innovative feature. We curved our rear air tube at 3 degrees. The curvature was introduced to improve airflow attachment and generate a small amount of downforce that caused stability. As we can see from our simulation, it is much better than this. And we also received some opinion from Bekasil Yelibai, who is IFO Silver winner. We generated this idea together with him. But it was still not that stable. As you can see from here, it is too much pressure here and it is too less pressure here. So we decided to make the final version. We changed the front wing to and shortened the nose, so it became more stable. We shifted also to the bottom, so the air, so it raises the air and it overflows the wheel correctly. Also, we keep the enclosed rear wing form and made a little bit broader and smoother side fairings. If you're interested, you can read from our engineering portfolio all the versions and like more exactly. Here you can see from the front and from the above. We also received some advice from Yer Sultan Pitibay, who is MIT student. And as you can see from our final CFD, it is much better than it was here because there was too much pressure and there was too less pressure. Then my teammate will continue.
So let's move on. Let's be short. Our physics mathematics section explains why our design decisions were not random. First, we use the drag force equation, and so just this formula shows the air resistance depends on the car shape, frontal area, and especially velocity because speed is squared. And that is why we focused on a smoother body, cleaner side fairings, and simpler rear wing, as Anastasia mentioned previously. And we also developed calculated different types of movements and just use it in graph, scale it in graph, and they showed that pretty good results. So let's move on manufacturing.
Hello, everyone. My name is Edrijan. Our manufacturing strategy is built around two principles. Regulation compliance comes first, mass optimization comes second. The body of our final car will be CNC milled from the official STEM racing foam foam block, as required by regulation. Every other component, wings, wheels, halo, tether guides, will be 3D printed in PACF and nylon reinforced with carbon fiber. Next slide, please. We selected PACF after weighing 7 criteria. It outperforms PLA plus in tensile strength and stiffness while being 11% less dense. For prototype, we use PLA plus because it's faster and cheaper to iterate. One critical lesson came early. Our first wings broke along their layer lines. The fix was orientation. Printed flat on the bed with layer spiral to airflow, the wing is almost twice as strong as printed on edge. Every aerodynamic part now follows this rule. Next, please. Our final target is exactly 48 grams, the regulation minimum. The body is the largest contributor at 38%, and we use lead ballast in the halo pocket as a tunable buffer to absorb material variance. I'm giving more to my teammate Damir to present enterprise portfolio.
Okay, can you hear me?
Yes, yes, I
Good.
can hear you.
Yes. Good afternoon, dear jury. My name is Damir. Today I will present the enterprise portfolio of Ogma Racing. Our enterprise strategy is built on around one idea. Ogma Racing should be seen not only as a car project, but as a recognizable Kazakh engineering brand. First, we developed a clear visual
Sorry,
identity.
your
Next
time
slide,
for
please.
presentation is over. You have 4 minutes for the Q&A. The time for Q&A goes in.
Yeah, so it was good technical presentation, but can I give to guys 1 minute to explain sponsorship strategy and marketing portfolio?
Okay.
Thank you very much. First, we developed a clear visual identity. The name Ogma is connected with knowledge, communication, and learning, which matches our goal to explain engineering in a clear and inspiring way. Please, next slide. Pink and black color scheme was chosen to make team highly visible and easy to recognize. Nastya, next slide. This identity is used everywhere on the car livery, logo, portfolio, presentations, Instagram team, including clothing and speed display. For marketing materials, we try to keep everything consistent. The car team uniform, sponsor visuals, and etc. Even material decisions were connected to enterprise thinking. For example, wood was used for low-cost testing, while polyacetal was used for the final model because of its balance, durability, and machinability in general. Our sponsorship strategy is based on clear value for partners. We created 5 sponsor statues. It's Apex, Accelerators, Impetus, Fundamental, and Faber, which is golden, title, silver, bronze, and etc. These levels explain how much visibility and involvement each sponsor receives. Sponsor value is not limited to a logo on the car. And sponsors can also be shown on the PID display in the portfolio on Instagram during school presentations and through educational STEM content. The PID display is on an important part of this ROI, since I want to mention that
thank you. Sorry for interrupting, but I would like to give a little bit more time to my technical partners to ask a few questions about their ideas.
Can you open your Fusion Twister 316 model and show your timeline?
Actually, can you explain how to do this?
In the bottom side, you have like
here.
Yes. Here you can one black. You should at the left side put it. Yes. And put between the how to say on the starting point. No. At the left side, put somewhere just tick on the starting point. Here is like a timeline. When
Sketch, maybe.
Yes.
Yeah, on downside, maybe you can sketch.
Yes.
Yeah.
Somewhere here. Yes. Open it. No. Yes. Edit sketch.
Okay.
Okay. And now can you make it back and show underside of your car? Under and the back.
We don't have text here. If you wonder about this. And also tutorial, like cars have logo here.
And underside.
We also have other fairings for better aerodynamics. And like decals for car designing. And here are our, we couldn't have time, but you can read from our engineering book. I really suggest, because there is a lot of information about our sponsors and our.
Sorry, your time for Q&A is over, and we are moving to the next team.
Question: how is your drag coefficient? How much is it?
Write in the chat.
Okay.
Okay. So the next team is Epic Explorer. The Epic Explorer, are you here?
Yes, we are here.
Okay. ITK, I'd buy, right?
Yes. But
So
my
I
full
made
name is
you.
Mohammed.
Can you share your screen?
How to?
We see your screen now.
Okay, let's begin.
Okay, you have 6 minutes to present. Good luck.
Okay, it's Epic Explorers team presentation.
Hello everyone, we are Team Epic Explorers. Today we are excited to present our a project for Steam Racing. We have put a lot of work into your car and we can't wait to show you results. In your presence today, we will cover a brief look at Formula Racing and introducing to our team the story behind your car and its development, technical details about the car's improvements and aerodynamics. Okay.
Вы что-то говорите, вас не слышно?
We cannot hear you. Could you please turn on your mic?
Sorry.
Слышно? Раз, два, три, раз, два, три.
Tarxon qilsaydi.
Formula One racing things, global racing competitions. Formula One Grand Prix are held across the world on the variety of circuits, showcasing international racing talent and excitement. Advanced engineering. Teams utilize state-of-the-art automotive engineering and technology to build fast, efficient, and reliable race cars. Starting teamwork. Something in Formula One relies on coordinated teamwork, pre-speed stages, and that drive decisions making during race. But this presentations will be about the miniature Formula One that's will now.
Now let's meet the team. We are a close-knit group of three. Basharat often is of the captain leading the project. Ait Mohammed is a lead engineer responsible for the technical build, and I am Kizak Dimash, the team's programmer. Together we combine our skills to bring this project to life. Next one. Our journey started exactly 1 month ago. It was a process of constant learning. Uh, operated the car frequently, balancing weight uh, reduction, the aerodynamics, attentions, reliability. We focused on the regular maintenance to ensure the car stays even for every run. Software to design and test ideas. We used professional tools like Fusion 216 and Autodesk CFD throughout the enterprise.
Our Formula One vision. All the angles will be shown in the following pictures. In the pictures, the project is industry at the top and spend more time on this 3D model that's expected.
Our castle aerodynamic was key focus on in the development of our Formula One model. To optimize downforce, the aerodynamics elements are designed to generate sufficient downforce, improving grip and stability, especially in cornering, to reduce the drag and optimize body shape, minimize air resistance, allowing the car to achieve higher speeds with better effectiveness. Performance balance, our aerodynamic design balance downforce and drag to ensure competitive performance control and reliability during acting racing conditions. About the improvements of our car. Our first version of
Sorry
car
for
was
interrupting, but
several issues.
your time for presentation is over. So you now have 4 minutes to answer questions from the judges.
Mm. Uh, all right.
Do you have 3D model of your model?
Yes, of course. We has had used Fusion 360 to model our car.
Can you move your timeline on the start of projecting your 3D model?
Yes, of course.
This prepared ready model you download it from internet?
No. This is our personal model that we made.
Mhm.
We didn't
How
download
much
it
time
from
did you
internet.
spend for the 3D modeling?
Sorry, can't you repeat the question?
How much time did you spend for 3D modeling?
Around months.
But we cannot see it in your timeline.
Sorry, what?
So if you've been developing it for months, there will be like steps in this timeline, but you're showing nothing.
Sorry, my fusion is lagging a bit. Uh, mm.
You can.
Okay. Sorry. Now it's working. This is a timeline of creating the car.
Okay.
About you said that you made analysis. What kind of software do you use, and what is your drag coefficient?
As I said before, we used Fusion 360 and Autodesk CFD for aerodynamics.
And the result?
Successful, I think.
No, numbers. Or you can
Numbers
show
of
it maybe.
iterations.
Yes, no, no. You can show it if you have it. Maybe show the how to say the
Yes,
analysis.
of course. It will take few
Okay,
moments.
no problem.
Do you have any research, like from real racing cars, when you make your model?
Yes, we read the rules carefully and
No, no, I mean, did you research some real racing cars? Or you
yes,
just made it
we
by yourself?
use tutorials on YouTube to help it to visit create our car.
Okay. I have one more question. What is aerodynamic and why is it important in racing cars?
Aerodynamics is an part of physics science, and it's
Sorry, your time
Idiot.
for Q&A is over. You can answer this in chat. So now we are moving to the last team today. It's the team last Shrod Thinkers. So are you here?
Idiots.
What? Shrod Thinkers, are you here?
Можно последнее слово скажу?
Yeah, we're there. Just one moment, please.
Okay. Please be a little bit faster as
Можно последнее слово
are.
скажу?
Yeah, can you give Sanjar permissions to share screen?
Okay. But it's Epic Explorer, no?
Yes, idiots. All...
What?
You can write in the
Можно
chat,
Who should
okay?
to share the screen? Who should?
You can write in the chat. Or you can send the pictures in the Telegram chat. Shrod Thinkers, are you here?
Yes, can you let Satan Sanjar share his screen?
Just a second. Can you share your screen now?
Sanjar?
Please be a little bit faster.
Wait a second, I need to reconnect.
Please, last team, be faster.
We're having some technical issues.
Could you please again give me the permission?
Okay, give the permission. Can you share your screen now? Okay, you have 6 minutes to present, and your time goes now. Good luck.
Okay, I am the team presenter. We are sure thinkers. Our slogan is think sharp, race fast. This is our team presentation. Please, the next slide. This is our team. Our team manager is me. Design engineer is Satan Sanjar. Our main engineers are me, Sanjar, and Janibek. Janibek and Yarasil are unfortunately ill today, so there will be only three of us, me, Sanjar, and Yistay. The next slide, please. This is our branding, our logo, our team name, slogan, our main colors, our identity, and our origin, Kazakhstan, Central Asia. The next slide, please. I want to start with the project overview, what we're building and why. The challenge, design, manufacture, and brand and race a miniature F1 car powered by an 8-gram CO2 cartridge over a 20-meter track as a part of the global racing competition endorsed by Formula One. Our mission is to build the fastest and the best engineered car from Kazakhstan by combining aerodynamics, CFD simulation, precision CNC machining, and rigorous data-driven iteration. The track is 4-meter, 4-lane tracks, and cars reach approximately 60 to 70 kilometers per hour. The scope, we need engineering portfolio, enterprise portfolio, car design and manufacture, verbal presentation and branding, sponsorship, and race day performance. The next slide, please. 3D car model and concept. Here you can see our inspirational model. We saw it from the official STEM Racing website. We really like the design and we designed the same thing, but the thing is that the force that was exerted by CO2 and its arm was too long, so the torque exerted by CO2 could easily flip over our car. So we reshaped and redesigned our model. Satan Sundar, next.
This is our 3D car and model concept, and we analyzed our car's aerodynamics and identified two strengths and two areas for improvement. Our first strength is a tapered nose cone and its contribution to good mass distribution. Its elongated pointed shape shifts the vehicle center of mass slightly rearward without adding structural weight, improving the longitudinal stability under braking and reducing front axle load spikes. Additionally, the tapered profile creates a gradual pressure gradient, reducing front end pressure. Track by end estimated 20% a direct benefit of how mass is disturbed along the chassis. Our second strength is the rear wing with the vertical end plates. The end plates prevent flip forces, vortices, increasing wind efficiency by around 25% and generating clear downforce. However, we identified two weaknesses. First, our weakness is our wheels are fully exposed. Open rotation wheel can contribute up to 40% of total drag. Our next iteration will add side spot deflector to redirect airflow around them. Second, our body has sharp 90-degree edges and flat sides. This causes immediate flow separation and turbulence. We will fix this. By adding smooth fillets and a Coke bottle narrowing towards the rear wing, targeting from 50 to 20% drag reduction. These insights drive our design iteration.
You can see how we redesigned our model. And we just recounted all of our engineering decisions. We can now start with the materials that we'll use to manufacture our vehicle.
Here's our engineering decisions. First of all, aerodynamics low profile with a minimal frontal area, CO2 canister placement, weight, wheels, and bearings and wings. You can see the other information on the right side of the screen. Here's our materials. First of all, we used balsa wood, ABS, nylon plastic, steel, bearings, carbon, and fiberglass, 8 gram CO2 canister, and filament and primer. Our project
line and timeline. You can see all phases of the actual STEM Racing World Finals. We are now currently on the phase 2. We did the 3D model in the Fusion 360, and we can now go to the team roles. As I've mentioned before, there are our team members and their roles. The next slide is our brand and marketing.
Moving to on our page visual strategy, our identity is built on 3 colors, racing red, midnight black, and gold. We have developed 3 distinct merchandise lines, team uniforms, racing kits, and the fan t-shirts. Next page. On the next page, you can see our reach targets. We plan to attract 10,000 followers through the social media by showcasing the entire engineering process, from chat designing to track tests. However, the centerpiece of our marketing will be a large-scale STEM exhibition, which we are organizing right out our school. This will allow us to demonstrate the car's capabilities live, engage a new audience, and to provide maximum exposure for our sponsors.
Your presentation time is over. Now you have 4 minutes to answer questions from judges. Good luck.
Can you open your 3D model?
Sure.
Which program you use?
We used Fusion 360.
Okay. Can you show downside of 3D model? And backward?
Can you show the history of your car? If you tap on the F STEM Racing on the left side, at the where is the browser, if the yes, no, on the STEM Racing, where is right side of the mouse? Yes.
This one?
Click on the right side or right
No,
button.
right click.
Right button.
Yes. Yes, history. Here is a history. Yes. Okay. What is about the CFD analysis? Do you make some kind of analysis?
Yeah, we
Yes.
made a couple analysis, but we don't have any files of them because we used them. We made them on another computer, and I don't have access for it right now.
What is your drag coefficient of your car?
Our drag coefficient is like
0.4.
It's like no, it's like on a high level because we have nice angle of the drag coefficient, and we have like our back is like flat, and the air just flow it like this and like this under and up. And also we have a big spoiler that allows us good downgrade of the back of the vehicle.
And how you plan to produce and manufacture your car?
Yeah, we have a lot of plans. For example, we can use wood plates like from 3 to 6 millimeters, and also we will for the vehicle material, and we also will use for the tires. We will use we will try to find new vehicles, the ready vehicles. But if you don't, we will also create them by ourselves using materials such as ABS plastic or like that. And also we will use bolts, M4, and this thing. Yeah.
Bearing.
Also, we have 3D printers.
Yeah, also have 3D printers, and also we can use both. For example, from made of wood and made of ABS plastic. It's allowed for us. Yes.
Your time for Q&A is over. So yes, that's it for your team.
Thanks for the good questions. For the judges, we'll leave now.
Thank you. Goodbye.
Goodbye.
Как ваши дела?
Слушай, ну сегодня, скажем так, средний уровень.
А YouTube отключили?
Сейчас отключу.
Аружан? И в Ютубе.
Думаю, что многие из сегодняшних участников смотрели вчерашнюю трансляцию, потому что прям видно, что учитывали определенные моменты, которые сегодня в презентациях у них появлялись. Ну, то есть